So this lesson is about using summation notation. This actually, if you take any math classes in college, whether it be calculus or statistics, there's a very good chance that you're going to see this notation. Okay, so here we have what's called a summation. We also call it sigma notation because this big thing that looks like an E, that's the Greek letter sigma. It's actually the uppercase sigma. You might see a lowercase sigma at some point. So then we call this I right here, that's called the index of summation. One, which this could be 0, it could be 8, it could be pretty much any number, is my lower limit of summation. And n is my upper limit. That word is limit, by the way. So basically what we do for this is we start at 1. Everywhere that we see an I, we're going to substitute in 1, then evaluate, then we add that. We do the same thing, then we go to 2. Everywhere that you see an I, you substitute in 2. You keep doing that until you get to whatever your upper limit of summation is, which in this case is called n. In the end, you're going to add everything together. Okay, so let's do some examples. For number 7, I am going to be finding the first 4 terms of this sequence. By the way, this summation is finding the sum of the first n terms of the sequence. So for number 7, my formula for the sequence is 5i. I'm going to find the sum of the first 4 terms. So my first term is 5 times 1, which gives me 5. Second term is 5 times 2. Then I have 5 times 3, followed by 5 times 4. If I add all of those together, I do end up getting 50. So that's my first sum. So then for number 8, I want you to notice that you do not need to start at 1. You can start at pretty much any number that's not negative and that is a whole number. So you don't need to start at 1. You will see summations that often start at 0. 1 is probably the most common, but 0 probably is next common. And then sometimes you see these things like this that start at like 4. So go ahead and pause, try this on your own. So then for this one, I'm going to start, I get 10 minus 4. That's my first term. Next term is going to be 10 minus 5. And then I go all the way up to 10 minus 7. In the end, I'm going to add all of these things together. And my answer for that one is 18. So for number 9, again, you're welcome to pause and try it on your own. We are going to start with 0. First term is going to be 0 plus 1 over 0 factorial. My next term is going to be 1 plus 1 over 1 factorial. My third and final term is going to be 2 plus 1 over 2 factorial. If I combine all of those together, remember 0 factorial is 1, I end up getting 4.5. So we're going to end with some properties of sums. My first one, this C, by the way, in math, whenever you see C used as a variable, that often just means it's a constant. Sometimes you'll see K also. If I have a sum of something that's a constant, what's going to happen is that you're not going to have anything to plug in your I values to. Actually, what will happen is however many terms you have, 1 to n, you're just going to multiply your constant by the number of terms that you have. I'm going to give you an example so you understand what I'm doing there. So for example, if we have the sum, we'll draw that a little bit better, from I equals 1 to 4 of 5. There's two ways to do this problem. I'll show you both. The first way is you write out all the terms and then add them up. So you'll notice I have nothing to put in 1, 2. So my first term, n equals 1, when n equals 1 is going to be 5. When I equals 1 is going to be 5. My second term, when I equals 2, is going to be 5. Third term is 5. My fourth term is also 5. If I add all those 5s up, I get 20. Faster way to do that is just to use the formula. I notice that I have a total of 5 numbers between 1 and 4. So I just do 5 times 4, and that gives me 20. So same thing either way. Okay, second property. Again, C is a constant. If I have a constant multiplied by a term, by the way, this AI is not a constant. Anything that has an I in it is not going to be a constant. Any number that you have, though, is going to be a constant. If you're not sure, this says not, by the way. If you're not sure what I'm talking about, I'll do an example in just a sec. So if I have a constant, I'm allowed to pull it out front. Okay, so let's do an example. So let's say instead of having 5, I have 5i. I am allowed to pull the 5 out front and just be left with I there. So then I would have the 5 in front, and then I would add up I equals 1 plus I equals 2 plus I equals 3 plus I equals 4. That's going to give me 5 times 10, which is 50. By the way, you might notice that this problem looks a little familiar. You actually just did this problem a few minutes ago. So if you want to see the other way to do the problem, just go ahead and look back at your notes. Okay, number 3. If you have two things added together, you are allowed to split them up into two sums. I'll go ahead and write that out. So, by the way, this only works if you're adding things, not if you're multiplying them. So the first one is A sub I. The second one is B sub I. So we are allowed to split those into two. This one you may or may not find to be easier if you split them up. It's up to you which way you want to use. So I'm going to show you an example, and I think we'll actually do it both methods. So for example, if I have the sum from I equals 1 to 5 of 3n plus n squared, I am allowed to split this up into two things. By the way, the 3n, I can pull the 3 out front too. You might prefer to do that. And I would just have 3 times the sum from 1 to 5 of n plus the sum from 1 to 5 of n squared. Go ahead and, I'm not going to write it all out, but if you evaluate this on your own, you get 3 times 15 plus 55, which gives you 100. Now, if you do this and you don't split them up, you will get the same answer. I'm not going to write it out, but if you want to try it on your own, you are welcome to do that.